Hi, my name is Hanan Tariq and I'm second year computer engineering student at UA.
This is the contents that we will be going over. First, the problem definition. Second is our methodology. Third, the design selection. And fourth, our HTML UNI. And finally, our challenges. And at the end, we will be showing you a video presentation of our prototype. First,
Problem definitions.
so before doing designing our prototype, we read over the request for proposal and see what is needed. We read that here the province of British Columbia that urbanization is becoming a problem and we need smart system to tackle those urban problems. Development requires many efficient systems, which can only be achieved by technological solutions. The government seeks smart sensor prototypes to make the citizens or city personal lives easier. With smart sensors, we improve efficient resource management throughout this BC cities. And the main goal is to optimize the various aspects of citizen living in urban cities. Next, please. Our objective is that the prototype or our proposed solution will be safe to its user, safe in general to use, and to its environment. It will have no environmental impacts. It in terms of energy consumption and being sustainable. It should be a straightforward system that anybody could use, city personnel, normal citizens of any age, and it should have a low cost in terms of maintenance throughout the years and even its installation costs. Our constraint is that we have to use the Raspberry Pico W as our main processor, sensors, and interacts with user interface with using HTML coding. Based on our objectives, we listed these criterias, user accessible friendly system. Like I said, it should be accessible by anyone. It should be a straightforward system. Environmentally benign is having no harmful impacts on its environment, and inexpensive to install is installation costs. We estimate the initial cost required to install each prototype, including equipment, labor, and any associated infrastructure modifications, and inexpensive to maintain or operate is estimating the ongoing expenses associated with operating and maintaining each prototype over its lifestyle should be reliable, measures the consistency and the dependability of each prototype's performance over time, ensuring that it functions as intended without frequent failures or breakdown, should be safe and durable, and that's mostly self-explanatory. No frequent breakdowns, should not be harmful to its users. Next slide, please. Selecting the problems, we realize a critical problem for British Columbia. We see it throughout many news that is forest fires during the summer times. Our group hopes to lessen those forest fires and improve public safety and preserve our environment through early fire detection. We choose to focus on forest fires in Canada due to their significant ecological and environmental and social impact. Canada has a vast forested areas that can be impacted by this, and it just overall is significant to our way of living. Even our major cities is surrounded by very forested areas, so it is connected to public safety as well. Next slide, please. Mythology.
Hanan.
Hi. So the solution we had was making a forest fire detection system. So what it basically involves is a thermoresistor connected with a Raspberry Pi. Our vision for this was based on the fact that Canada experiences a lot of forest fires. So that's why we decided to make this simple solution, which can be installed anywhere and which can work absolutely fine in terms of detecting the forest fire. So for the next slide, we'll go on design selection. The components we used were obviously the Raspberry Pi, the thermoresistor, our power supply unit, wires, LEDs, and resistors. And we used two resistors, one of 1000 ohm and one of 330 ohms. Now moving on to the next slide. So this is a small photo of our prototype. You can see that here the thermoresistor is connected with the resistor, which is then connected to the Raspberry Pi. We also have an LED installed in the circuit. So what happens is if we bring anything near to this resistor, which has flame and heat, the resistance drops, which in turns on our LED signal and indicates that a has been detected. So moving on to the next slide. We
HTML
have
UI.
HTML UI covered by.
Um, so this is the UI I've made using HTML and CSS. Uh, for the photos, I've used SVGs so that it's accessible and it's easy to understand by anyone who's looking at the website. This UI has been designed in such a way that it's really easy to understand and accessible by every person so that it's easier to detect fires. So we're gonna have two UIs. The first one is the green one, which is being shown to the user when the forest is safe. And I've used the colors in such a way that it shows safety and that everything's fine. The next one is whenever on the circuit, we see that the thermoresistor sees that there is a spike in temperature and there might be a risk of forest fire. We see this UI. This has a red color which shows that there is a risk. And also on the bottom, there's a button which when you click upon, it redirects and you're able to call the municipality or the forest department, which can then take action. Moving on, we have the challenges we faced, which is
So our challenges and our team are in creating this prototype is time management. We all have busy schedules that we had to collaborate on and like see which of our free time connects. Teamwork, like any other group work, we had to learn our strengths and weaknesses technically or any type of skill. And HTML coding is mostly trying to figure out it's a new language for some of us, a new coding language for some of us, and we had to think of how HTML coding we can apply to make a great user interface that will be simple enough to show accessibility. And our learning is that applying the knowledge from the lab work into this project, the different sensors that we can use, the function of the Raspberry Pi Pico and coding is our how we put our learning into this project.
Also, one more problem that we really faced was during Wi-Fi integration, which was when we connected to our phones using the Wi-Fi integration, and we did not disconnect while we were testing. If we did not disconnect and then we tried to connect again after we made the changes in the code, it said that the port is already in use, which really we caused a lot of difficulties for us since we had to remove the wire from the circuit again and again. But yeah, that was one of the other challenges we faced during the testing phase. of design. Now moving on to the video of the prototype, we could have a
So this is our group prototype, and right now the temp is normal, which shows that LED being off and there is no risk of forest fires. But when there is a fire nearby and the temperature spikes, you can see that the LED turns on because the thermal resistor which sends the fire lowers the resistance and turn on the LED. And this device will help detect forest fires in many cities and alert city personnel.
So this UI is going to be seen by the user when the LED on the circuit is off. This shows that the temperature is low and there is less risk of forest fire. And this UI reassures the user that there is no risk of forest. As soon as the LED turns on in the circuit, the user is going to see this UI. This UI shows that there's more risk of forest fire, and the user should take the appropriate steps and prevent the forest fire from growing too much. They can do this by clicking the notify button, which calls the forest department, who can then take action on the risk of forest fire and prevent any forest fire if necessary.